Hello everyone. Today we will study about the pressure belts of the earth. It is not something you memorize from a map. They are the natural outcome of three forces working together: differential heating, gravity, and Earth's rotation. Just remember, heat lifts it, gravity pulls it, and rotation twists it. If you understand the mechanism, the latitudes become obvious.
So, what is pressure? Atmospheric pressure is the weight of the air column above a given surface. At sea level, it is roughly 1013.25 millibars. As altitude increases, the air column above reduces and pressure drops. This vertical pressure gradient is the foundation of circulation. Without it, there is no rising or sinking motion. Most students rush to belts without understanding this base physics. Now separate the two drivers clearly: thermal and dynamic. Thermal control is straightforward. Heating causes expansion, density decreases, air rises, and surface pressure drops. Cooling causes contraction. Density increases, air sinks, and surface pressure rises. Dynamic control is different. Air may rise not because it is hot, but because it is forced upward by convergence or collision. If you cannot distinguish thermal from dynamic belts, you will misinterpret statement-based questions. Now add Earth's rotation. Air moves from high pressure to low pressure. But because Earth rotates, that movement bends. Northern hemisphere deflects to the right. Southern hemisphere deflects to the left. Zero deflection at the equator. Maximum near the poles. If you don't mentally lock the hemisphere first, you will answer wind direction questions incorrectly. Now lay out the framework. At the equator, you get an equatorial low. Around 30 degrees, subtropical highs. Around 60 degrees, subpolar lows. Around 90 degrees, polar highs. This pattern mirrors in both hemispheres. Now we justify every one of them. Start at 0 degrees. Maximum heating occurs here. Warm air becomes lighter and rises continuously. Rising air removes mass from the surface column, creating low pressure. This is the equatorial low. And rising air means convection, cloud formation, and heavy rainfall. Permanent uplift equals permanent rain zone. Now follow that rising air upward. It moves poleward, cools, becomes denser, and descends around 30 degrees. Descending air compresses and warms, suppressing cloud formation. This creates subtropical high-pressure belts, and this is why major deserts lie near 30 degrees. Sinking air dries regions. That linkage alone explains Sahara, Arabian, Australian deserts. Now move to 60 degrees. Here, warm mid-latitude air meets cold polar air. They collide. The warm air is forced upward. Forced uplift creates low pressure. This is the subpolar low. This region becomes the storm track belt with frequent cyclones and frontal systems. Do not confuse this with thermal low. This is dynamic uplift due to collision. Now go to the poles. Extreme cold makes air dense. Dense air sinks. Sinking air builds polar high pressure. And remember this carefully. Poles are cold but dry. Cold air holds very little moisture. Polar regions behave like cold deserts. Now connect belts vertically through circulation cells. From 0 degrees to 30 degrees, Hadley cell. From 30 degrees to 60 degrees, Ferrel cell. From 60 degrees to 90 degrees, Polar cell. Hadley and Polar are thermally direct. Ferrel behaves like a linking system shaped by surrounding circulation. If you understand the vertical loop, you automatically understand trade winds and westerlies. Now extend the understanding beyond north-south. Pressure differences also occur longitudinally. Walker circulation across the Pacific is an example. When pressure patterns shift east-west, rainfall belts shift. This is directly connected to El Niño and La Niña. Pressure belts are part of a larger, coupled ocean-atmosphere system. Now add seasonality. Pressure belts are not fixed lines. They migrate north and south with the sun's apparent movement. In summer, they shift toward that hemisphere. In winter, they retreat. The most important shifting belt is the ITCZ. Monsoon is fundamentally about this seasonal migration of pressure belts and cross-equatorial flow. If you reduce monsoon to land heats faster, you are oversimplifying. Now consolidate the structure clearly. Equatorial low to thermal origin to rising air to rainfall. Subtropical high to descending air to dryness and deserts. Subpolar low to dynamic collision leads to cyclones. Polar high leads to thermal sinking, leads to cold, stable conditions. Thermal belts are heat-driven. Dynamic belts are circulation-driven. If you can derive each belt from cause rather than memory, you have mastered the logic. Now, final exam filter. Horse latitudes are associated with which belt? Subtropical high pressure belt, around 30 degrees, not the equator. If you mix up 0 degrees and 30 degrees, you lose an easy question. Next concept, Aurora Borealis. It occurs in the upper atmosphere, primarily in the ionosphere or thermosphere. Pressure belts operate near the surface. Aurora is an upper atmosphere electromagnetic phenomenon. Keep domains separate. Surface circulation is not the same as upper atmosphere physics. If you can separate mechanisms cleanly, avoid traps confidently, and derive belts logically, you are exam ready.